All right, hello everybody, and thanks for joining. Sorry, give me a second right here. All right, we're back. Yeah, there was like this stupid logo thing was showing, and it was really bugging me. So last time I had like a huge headache, and we were streaming, and everything was like trying to push through it, and then suddenly we were like, nah, I can't do this, and I literally had to like go take a break. And I tell you what, I was so damn exhausted. Like, I'm so glad that I dropped, because honestly, I was dying. So we got through a bunch of stuff. So let's kind of reorient. It's been like almost 2 weeks now. So let's get to it. So what do we have left? Last time we were discussing that we're changing our model a bit to use user owns a document straight. So there is no concept of a root document for now. And if we need it, we'll add it. So that's fine. And we went into the repository, like the mock repository, the in-memory, and we refactored it so we don't have to include any documents from the get-go. And then we also went and refactored our test. We did the table-driven test at one point where we needed to check that the parent is relevant, but here we're no longer doing this. And you might be wondering, well, how we gonna include a document nested in a document? Well, in this case, we will refer to it as a segment. So when you nest document within each other, a document will be just a segment of another document, but the only extra property that it will be added to the inode table. And I think we will get into that today, so I don't want to over-explain it. So we started working with the Neo4j driver, right? And we installed it last time. At least, yeah, that's what I tried to do last time before I got really sick. So let's kind of see what we did here. So we did go get, right, and you do the Neo4j driver right there. And that Neo4j driver is honestly like some of the best Go code that I've like seen. I know they're trying to be consistent with their Java, and because that's the primary language that it's written in, and it's cool, but like honestly, it's a very well written library, and I think I've learned like a lot actually from it. So all right, so what are we trying to do right now? I'm trying to save a document into the database with bare minimum work. I want to even like add the authentication into the saved document right now, once we integrate with the database and we're able to actually communicate and open a transaction and we go from there, what we'll end up doing is we'll go back and refactor this piece of code right here. Because right now, you never want to have your username and passwords just kind of like being called in every time of the function. You can authenticate once and then just reuse that connection, or have at least a cleaner way of doing it. We also got to look into how we can handle different errors, right? But for any case, we started by creating so in Neo4j, the driver, you create a new driver with a context. And essentially what this allows you to do is that you pass your URI, which is the endpoint you're going to connect to. If you're developing locally, that would be like your local host. I am using Neo4j Aurora. So because of that, everything is like here. So I have that URL right there. I've set up my username and password in the environment variable. And we will talk more about configuration files with the amazing library called Viper or Golang. And Viper is actually powering like shit ton of applications. So have you ever heard of Kubernetes? Or have you ever heard of like, I think it's doing that with Docker as well. I'm trying to see if there's like projects. Many Go projects are built using Viper, including so some of the Docker stuff. Hugo, that's a static file generator, a static site generator, and a bunch of other. But anyway, it's a pretty solid library. I only played with it like literally the same day, so we will get to have a look at it, but we will learn as we go because that's what we do. Great. That's what we do in the stream, by the way. Outside of the stream, you should go and learn and explore by yourself without having to learn on the job. One of the best things you can do for yourself is to actually spend some time learning the things before having to use them. And this way, when you have to use them, you have much a wider perspective about what you'll face. So yeah, keep that in mind. So anyways, we will use Viper now. Well, not now. After we establish the authentication, we'll use Viper and look into how we can pass configuration, what is configuration files. We even might explore hot reload. I know Viper supports it, but you also need to kind of tell your application, like, once this change, do these steps. Viper makes it really easy for you to be notified when your configurations change, but we'll get into that. Anyways, let's look into the save document. So, okay, we established the URI. We had our username and password set up as an environment variable. And we did like a very trivial validation here. It's like, if your username and password are not set, give me an error. Return an error, I mean. And then we started with the driver here. And we're actually ignoring the driver variable for now, because we just want to make sure that we're even able to establish a connection. Once we establish a connection, that's what we're gonna do. And here's kind of like the pattern that I left over last time. I think nobody really watched the last time because I was so tired and I click on end stream and I didn't actually publish it. So that was gone. So we'll go through these things again, you know. Let me just make sure that everything is going okay in YouTube side. Great, great, great. Wonderful. All right, so I'm gonna move that here. You don't need my terminal right now. What else? Okay. So the save document will be past the document and it should operate. We talked about the validation. Now the driver, the big part. So you pass your URI and you pass an authentication function. And you're doing the whole functional configuration thing, which is super cool because we talked about this the very first stream, I believe. And And now you can actually see it in real world projects, right? So if you see here, you can see like they're passing your configurations as a bunch of functions, right? And they're doing kind of similar thing for authentication. So you have different authentication mechanisms. So anything that have get auth token and on token expired would be qualified as a token manager, right? And you have some concrete types like the auth token. Actually, you can click here and you would see your types. So these are the things that actually implement those interfaces. So you see the auth token, right? Which is, it contains the credentials to be sent over the Neo4j server. You can kind of think about it just like basic auth, which what it is, guess what? It is basic auth, right? So yeah, we will not talk much about the realm because we don't have like different databases just yet, but we will get into that eventually, right? Yeah, so you can see here like they can even like pass like bearer tokens, which will be added to like your HTTP header. And yeah, they're like pretty well commented, and like you can use Kerberos. I never really knew how to pronounce it, so yeah, so be it. Anyways, so back to the actual mission in hand here. All right, so you pass a URI, you pass an authentication mechanism. We opted in for basic auth for now, and we will abstract this a bit, or not abstract it, but we'll isolate it a bit. So if we ever change our mind about our authentication, we should be easily able to do that. And then you can pass configuration functions, and the configuration functions would allow you to configure how your connection would work. Just so you know, though, if you go to the Neo4j and you look into the config functions, I think in their documentation here, let's see. Bam. We should actually go to the version prerequisite. Okay. Documentation in depth here. Sweet. So yeah, so they updated this to use the config.config. So before it was different. So actually, like even if you try to do like a function here, it will opt in for the Neo4j config object, which is being deprecated. So if you look here, it will says that it is deprecated, right? And now it points you to use the config directly, which you have to do the config.config, right? So config.config, and that is coming from Neo4j right here. So great. Okay. I just wanted to clarify this because a bit older code bases, including mine, really was using the deprecated one, and it's only recently deprecated. So yeah, it's good to be aware of that. So here we have like the full documentation about the driver. We might just skim through it before we go implementing. So let's have that together, right? Neo4j client application requires a driver object, which from a database access perspective, forms the backbone of the application. It is through this object that all Neo4j interaction is carried out, and it should therefore be made available to all parts of the application that requires data access. Okay, so really they are giving us the path to kind of make the driver maybe a struct field, right, is something that anything that's talking to the repository should be able to have access to that driver. All right. In languages where thread safety is an issue, the driver object can be considered thread safe. That's huge, because if they're able to guarantee thread safety, which we will eventually have to face anyways, then that's a lot of work being taken care of just by the driver. And that's what I mean. It's just brilliant. A note on lifecycle: application will typically construct a driver object in a startup and destroy it on exit. Destroying a driver object will immediately shut down any connections previously open with the driver object by closing the associated connection pool. This will have consequences of rolling back any open transactions and closing any unconsumed results. So that's important, right? Because if at any point you have your driver like being garbage collected, or you just destroyed it somehow, all your concurrent operations will just be dropped or rolled back, right? So that's something that we really have to pay attention to. And again, right now we're still doing like the baby steps, the fetus of the application. That's nothing yet, right? But when we get a bit more with the requests coming in and concurrent operations, we have to start thinking about all these things. Okay, so here to construct a driver, we need a connection URI and authentication information. Done. Additional configuration details can be supplied if required. Okay, we already spoke about that. So here we can look into the create driver function, which you give it a URI and a password, and it should return the driver with a context for you and an error. So I'm thinking right now, rather than us consuming the driver directly, is it possible for us to use the create driver function? But just looking at the function, you can tell that it is not exported, because exported functions in Go, they start with a capital letter, but this is not exported. So how can we use that? And I believe that this is an example that they're showing. Is like, hey, do a function called create driver that you can reuse to return the driver, and a function to destroy the driver, which is what's called driver.close. All right. Connection URLs. We're not really going to talk about this right now, but it talks about like the address resolutions and more stuff related to like how you actually reach to the database, which is important, and I think we should totally know and be aware of it, because if you notice here, there is replicas, and Neo4j is a cluster database, which means that you can have multiple instances running and all being replicated, and you have all that beautiful distributed system things to ensure reliability, right? And like to make sure that you have durable data across replicas, and if one is under pressure, you can work with another one. But whenever you distribute, nothing comes for free. So if you have high durability, usually you face a lot of consistency issues, which means that you cannot have high consistency, like immediate changes pass through all the replicas. Meanwhile, you also have as many replicas as you want. It's just the theory doesn't really support that. So that's why when we come into things like eventual consistency, which that word is like used a lot, and yeah, anyways, like my point with eventual consistency is that the idea in itself is very simple, right? Is like you're trying to send a message, to something, this something will need to be replicated. So it needs time to be copied from one place to another place. So now if you make a request to that second place, you wouldn't really find your data being updated there, but it will eventually get updated. And that's where the word eventual consistency came from. All right. We don't need to worry about custom address resolver for now. Routing tables, we don't have to worry about any of that. Basic authentication, connection timeout. We'll look more into the configurations and the details of that a bit later. Cool, they even talk about like you can configure the logging, which is something that we need. I honestly need to look at like at a consistent pattern for doing logging in Go. I haven't really fell in love with any yet, but we'll see. All right, so here's the Cypher workflow. And this is, once we read this, we should be able to go and implement some of our saved document. And we also created a test. And the purpose of that test, this is a test that we're actually gonna redo. And as you can see, we wrote like bad test, we will refactor it. But the whole concepts about this integration test right here is to make sure that like, hey, can I connect to the database? Am I good to go? And if that passes, we can start looking into our business logic and what we need to get done. So, okay, the driver exposes a Cypher channel over which database work can be carried out. Work itself is organized into a session, transactions, and queries. So you have a transaction which would have multiple queries, and I'm not really sure what they mean by the bookmark here. Session, another transaction, another transaction. Okay, so conceptually, I think we can think about it. You have a session, and that session can include multiple transactions, and these transactions usually carry like a query or a mutation that you're doing, right? Sessions are always bound to a single transaction context, which is typically an individual database. Using the bookmark mechanism, sessions also provide a guarantee of correct transaction sequencing, even when transactions occur over multiple cluster members. Okay, and here we're getting into interesting distributed systems concepts, right? Which is called casual clustering. Casual chaining, which is a mechanism to ensure that the transaction carried out in a series are executed in order, even when each transaction may be carried out on different cluster members. So if you have multiple Neo4j clusters and you're operating into different transactions on across the nodes, right? I feel like it's usually just easier to draw things. So here you have node 1, node 2, node 3, and all of these nodes are part of the same Neo4j cluster. Great. So, right, and now you have a simple client that is trying to talk to these. So if we right, and you have another client that is also trying to talk to another node. So you are within the same cluster. Now that we have a visual representation, let's read it again one more time. So it's a mechanism to ensure that a transaction carried out in a session are executed in order, even when each transaction may be carried out on different cluster members. Okay, so we need a correction here. These are sessions or transactions, right? And they're referring to, great. Okay, so each of these arrows here represents a transaction, right? I want to make it as big as possible. Bam. Transaction. Bam, bam. I don't know if that's visible enough for y'all. Okay, so this is your client, right? This is our Golang driver that we're using. And now you are within a single session, but a transaction could be possibly talking to different node. They're all part of the same cluster, right? But you need now to make sure that if this transaction finishes before this one, that this sequence is guaranteed. And Neo4j is doing that for you using the concept that we just learned about, which is called casual chaining. All right, so let's move forward. Now, what is a session is a lightweight container for casually chained sequence of transactions. They essentially provide context for storing transaction sequencing information in the form of a bookmarks. I should probably do a session about like a deep dive about what is bookmark and distributed systems, because I honestly don't really know. And I think that would be a great learning opportunity for us here. So when a transaction begins, the session in which it's contained acquired connection for the driver connection pool. On commit or rollback of the transaction, the session releases that connection again. This means that it's only when the session is carrying out work that it occupies a connection resource. When idle, no such resource is in use. Okay. So interesting thing here, there's a connection pool that Neo4j driver will essentially reuse. And when you try to commit, once you're done the work, the session will release that connection again. So that connection will go back to the driver pool, the connection pool that you have. So when a session is carrying out work, it occupies the connection. But when it's idle, you don't have, you're not consuming any connections that you shouldn't be. And you're just saying, hey, Neo4j driver, let's say I have 6 connections, right? So you can run simultaneous 6 connections, for example. And I have 2 sessions working. And now one of them is done. It wouldn't just continue keeping that transaction held, right? And that's important because a lot of the times, if you're using other databases, you will end up having like resource leaks, or you can establish more connections because like you've exhausted how many connections you open. And that just typically happens because like you would establish a connection and never release it. So the driver is kind of like taking care of that for you. Okay, so in this paragraph, it says sequencing guarantees by a session. So because we have a sequence guaranteed by a session may only host one transaction at a time. So if I'm using a session right now, I can only run one transaction at a time. If I want to do parallel execution, I can have multiple sessions, but it is not considered thread safe. So you will have to do the locking or the synchronization between your concurrent code to make sure that things run in the order they intend to. And of course, closing a session will close, will roll back any transaction or like close it, right? So we have to be careful that we don't early close before committing or making sure that we're in a good state. Sessions are bound to a single transaction context. So specified on construction, Neo4j exposes each database inside its own context, thereby prohibiting cross-database transactions or sessions by design. Similarly, sessions bound to different databases may not be casually chained by propagating bookmarks between them. I'm not really sure that I get it, but that's okay. We can always get back to it. Individual language drivers provide several session clauses, each oriented around a particular programming style. So each session class provides a similar set of functionality, but offers client applications a choice based on how the application is structured and what frameworks are in use. Okay. All right, we also have the session API that we can look at, which is actually the next one here. But I want to get, like, I don't want to talk too much about casual chaining right now and the routing. I don't really think this is exactly what we want, but we need to skim through here to kind of know what's ahead of us and be able to like refer back to the documentation when we're stuck, right? Okay, so let's have a quick look at transactions. So transaction are atomic unit of work containing one or more cipher queries. So they may contain read or write. Generally, they're routed to an appropriate server for execution, which they will be carried out in their entirety, right? So in case we face a failure, the transaction needs to be retried from the beginning. This is the responsibility of the transaction manager. And I am sure that the transaction manager is something that we can configure as we wish. Yeah. That's actually a very common concept in like dealing with databases that allows atomic commits. Is like, hey, what should I do if I fail? You know, like, I don't really understand your business. Like, for example, I might be creating a part of a document, for example, and I'm trying to like tag someone into my document right here. And when I try to tag them, right, it just, that commit fails. So now, should I retry tagging them? Should I send them an email? What should be the next order of like business here? And these are usually for you to decide, right? So now the Neo4j drivers provide transaction management via the transaction function mechanism. This mechanism is exposed through methods on the session object, which accepts a function object that can be played multiple times against different servers until it's either succeed or timeout is reached. This approach is recommended for most client applications, okay? Also, there's a convenient short form alternative is the auto commit transaction mechanism. This provides a limited form of transaction management for a single query transaction as a trade-off for a slightly smaller code overhead. This form of a transaction is useful for a quick script and an environment which high availability guarantees are not required. It is also required from the transaction for running Cipher manual queries, which are the only type of Cipher query to manage their own transaction. A lower level unmanaged transaction API is also available for advanced use cases. This is useful for an alternative transaction management. Great. Okay. So now let's really get that freaking document saved to the database, right? So here we have database and execution context, the database selection, and now it's like we're getting into enterprise features, but I'm not really sure what they're referring to. Okay, so this is just an example, but I'm not really sure what is here that is considered enterprise. So here they're starting a transaction. You run into the transaction. Okay. Oh, so here, oh, I see. So here they're using different databases, right? So that's the use keyword. Got it. Okay. All right. Let's get coding a bit. All right. So here, first off, let's run this test and see what happens. Pum pum. So we're in the bounded context, the documents in the repository. Go test -v, and you run with the tags integration. Oh, by the way, in case you didn't notice, we put the directive go build with integration here, so we can run tests, right? And indeed, that test actually succeeded. Oh, I can even do it like that. That's fine. You can still see it. Okay, so that test has succeeded, right? So this means that we're able to establish a connection. Ignore the X from here because now we're running from this part because we have some environment variables that we wanted to set. And yeah, like I don't want to configure it in the Golang editor themselves. I just want them in my environment, so that's okay for now. Great. Excuse me. All right. Okay, so we actually need the driver because we're gonna start using it now. So if everything is okay, we can start saying driver dot, and let's see. Well, we have a session, we have a bunch of different options here, and we understood that to create a transaction, you need a session, right? And this is the benefits of like actually going through the documentation rather than just going through an example. So here, the session would require a context and a config session. So we don't know what our timeouts rules are going to be, and these should be part of the configuration. But for now, I will do context. So I'll do like the context package dot to do. And we usually just refer it as CTX. And here That was just the auto import. Great. Okay, so we have the context, and the reason why we put it as to do for now is because we haven't really decided what we're gonna do with it. Another option is that you say context.background, right? But you still, this is an empty context, so wouldn't actually time out just yet because you haven't specified any timeouts for it. But okay, we'll pass the context. Now, what else? So now you can also pass a session config, which, as we can kind of guess, it will have to be a function that takes a session, probably Neo4j session config, and returns an error. And cannot use function type session Neo4j. Okay. Cannot use function session Neo4j session config error, which is of type function session, okay, which is of that exact type as the type session config function. All right, so best ways that I do these now is I just go here and I look for what is like the session config. Okay, so here it actually takes a config object, right? So I misunderstood that. So here you say session config and bam. Right, so you create a session and you of course an error. Is it requiring an error? Oh, it returns a session context. Great. Okay, so now we do have a session. Now what we can do with this session? We can carry out transactions. Right. So you can use the run, but you have implications with that, right? And I think the run is actually the automatic mode transaction that we're talking about. Automatic. Yeah, a transaction on database foo is started automatically with the first query targeting foo, and that's because they're using the run method. Yeah, we literally just read that somewhere here together, but anyways, that's fine. Yeah, the auto commit, right? And just so we know, we can always go, I think it's F1. So run execute an auto commit statement and returns a result context, terminating too early negatively affect connection pooling and degrade the driver performance. Okay, so I want to go with the stronger route of running the transaction rather than just using run. So in that case, we're gonna execute a write, right? Or you can even say begin transaction, but let's explore execute write first, and then we can use the run transaction. So it says here, execute write executes the given unit of work in access mode write transaction with retry logic in place. Okay, versus what if we do session and we say begin transaction? Now what's the documentation of that? So begin transaction starts a new explicit transaction on this session context. Terminating too early, again, same warning about terminating too early. All right, I think the execute right should be fine. So let's go down this route for now. So we need to pass a context for it. And we already have one that we just created. Right. Here's something that we want to kind of like discuss. The context that you're passing to the session doesn't have to be to the one to the right, because you can say, I only want my writes to take a maximum of like 500 milliseconds. And if it takes any longer than that, I want it to fail. But my session, for example, I want to be able to take maybe 3 seconds to establish an initial connection and have that session, right? It's up to you. That's the point. But the point is, you might have different timeout rules that you want to specify. And if that's the case, you can just add it to the new session, like share a different context between the session and the execute write. So anyways, we have the execute write, it takes a context, and now it takes work, right? Which is a transaction actually, and some configurations. Okay, so now if you do this, which is a function that takes in a managed transaction. So this is a transaction that is managed by the driver for you, and it returns any or error, right? Here is what we can do. We're saving a document. You can technically return the same document back. And if that's the case, you can say, hey, I want to return a document type. All right, so now you have this transaction, but you're not actually returning anything yet. So we're just gonna say return the document in a nil. Okay, but now it's still complaining. So let's have a look. What is it complaining about? Cannot use the function. Okay, as we're using it right now. All right, so it's complaining about how we're using this function right here, right? And even if we have it as any, it still complains. So that is because the execute write, once we go to the code, you should be able to see that there is a generic version that you can specify, and there is one that is based on interfaces. This function that we just passed here is probably the older version, the one that is passed with an interface. So if I go to managed work, right, you can see here it's saying a type any, okay? And a type any is just really an interface. There you go. Which is not what I want to do, because there is typed version of this that you can use with the Golang generics. We just have to find what was the right function to pass there. So if it is the managed transaction, I'm trying to find out where that part is. Okay, let's look into session execute right. So here they're even using that any style. Which I'm not against, but I'm pretty sure there was a way to use generics in the Neo4j driver. We'll just have to do maybe a bit more digging. Maybe it's in the actual transaction. Um, okay. Well, let me have a look into a previous code base of mine. Yeah, like you should be able to return really anything you specify here. So why was it complaining about the document approach? Right. So if I do now it complains. Even if I do like that. Because you see here in this example right here, right? I'm creating my session, no problem. I have my execute right. I have my context, my session, and then I'm saying I'm gonna return a string. So if I'm returning a string, then what's the problem? And here, like I'm returning something completely different, right? Yeah, like here I'm returning a whole different struct. So I'm just a bit confused about what the difference is here. So these are execute read, but it shouldn't really matter. So like, I mean, we're definitely doing it right, so we need the right, but so here, my session, my context, this is my function here. Sorry guys, that's a stupid me thing. Because here, we're actually saying session execute right, and this is not what we want to do. What we want to do is Neo4j execute right, which is actually uses the generic version, And here you just pass it the session. And now that works. And now execute, if you go back here, this is the damn generic thing that I was referring to. It says execute write executes the given unit of work in the right transaction with required logic in place. This is the generic variant of session with context execute write. Right? So use this. Anyways, yeah, I could have sworn that like I've seen the generic code for it, right? Anyways, so now that I'm able to run execute, I have my transaction right here. Execute write should return an error for us, I believe. Well, it actually returns the type, whatever type you specify, and an error, right? So I can do here, say document.documents, right, as the type that it returns of this. But we don't even need to, because regardless, this all will be inferred from here. And so, okay, so with generics, I don't have to repeat myself multiple times. So what I can do is this type is going to be equivalent to that. So if I change this here, for example, it will complain because that's not the type that is specified. So now it is fine. If I remove this altogether, it will infer the type from whatever the return type I specify here. So that's great. Okay. Now what did I want to do? Now we actually need to work with the transaction. So we have the transaction, and now we can write our very first Cypher query. So you can say Cypher is going to be something like this. We're going to say merge. First off, let's make sure that we have the data required, right? What I mean by this is the document has an ID, has a name, and has a list of documents, but we didn't get the user that is creating this document. And for that, we need to pass it in somehow, right? And now again, we're faced with another choice. Do we pass the user ID in here or not? And in memory repository, we didn't really face that issue because we didn't have to worry about the user because there was no actual user, and we're just kind of like trying to test if things are being added or not. But in this repository, what we actually need to do is to make sure that the user has an ownership of the documents that it's being created. And to do so, we have a couple of options. One option is to pass the user information into the context and then use it. So you can think of the context as like a bag that holds information, and you can pass it down. The main idea of context is to be able to communicate cancellations. So like timeout. Hey, you have timed out, right? Or like that was kind of like the main purpose of context, but you can also commonly use it to add like user headers and things that identify the current user of that request, and you just kind of like have access to it. But it's very easy for us to do so, right? Like, just so I kind of like show you, you say, hey, context dot value user, for example, and you get like user ID, and here you can say user ID, right? And it returns any value, so you can say user ID as a string, And here you can cast it, or you can just like use it straight up like that if you wish. I don't even know if you can do this. Yeah, you can do that if it exists, but if it doesn't, it will panic, right? So typically you'll say like context with value, user ID, and then you'd say like user ID and an error. And what you will do is you'll say, can I cast the user ID dot string? And here we're not really assigning anything new. So now we can check if error it's not null, you like fail, right? So like for us, let's just panic. Of course, we shouldn't be panicking in the middle of a repo, so we can just really return the error. And like propagate, right? So like document, you return the documents, an empty document, and the error that we want to. But now it's still complaining, right? And that is because because is string yeah, I wonder if I can do it like this. Let me see. Yep, that should technically work. But even before doing anything, I want to run the code and kind of like show you that this is, let me panic here. Okay. What did I want to do? Go test. Dang, it is taking some time, eh? One second, guys. My computer has been acting up. Let me pull this out just in case I need to interrupt any process. I can actually just do that. So it says that this is okay, but really it shouldn't be okay, right? So the new for JRepository tests a document right here. That here should fail because repo save document should go all the way to the execute, right? And should really run this code, and then it should panic that it couldn't find the user. So let's even like print line is string. I don't know why it's taking time. It really shouldn't, but something is strange. That's what we pull. The good old PS and grep. And we search for Go. And we can kill -9 that process. Okay, so we killed it. And let me see Go how to flush cache. Okay. So this took 34 seconds. That's a bit more than half a minute. And I'm not really sure why, and we should figure that out. Okay, so here we're just gonna say I want to see if it's kind of like pauses somewhere. So it created repo and it says saving document. So now most of the time is being spent here, right? And I really would like to know why. And I'm doing like the bullshit way of debugging right now, because technically I can just run the debugger, but I okay, so looks like once we hit that new session is where things starts getting like very slow, and I'm not really sure why, but again, let's try to figure it out. Okay, we don't need any of that right now. So now the question is it the session? I'm trying to cancel it after 10 seconds to see if it's like the time is mostly taking creating the session or not. Because regardless, it honestly shouldn't take that long. Like we haven't done anything really yet to have like bottlenecks. Right, so looks like the problem isn't really the session. The problem looks like it's coming from the execute right. Says unhandled error, but then it complains about it, so great. I don't really care what type it returns for now. Okay, so we've got a panic here, and this is coming because of the cancellation, because we have, okay, so we have a few things happening, right? One, we reached the deadline, exceeded, because we set it for 10 seconds, and it exceeded maximum retry time, which is a total of 30 seconds. for 5 attempts. Right, and this means that the execute trait is for some reason taking such a long period of time. Okay, now we just kind of have to figure out why that is happening. So let's use just context the background for session. And let's rerun this again. Right, and here it will miss the return. And I'm now getting closer to, I think, a hunch. So yeah, the context deadline exceeded again. So we created the driver, that's fine. We go to the context with timeout. Okay, never mind, we're not really using it for the session. And then the execute try it starts a transaction. And I'm doing something weird here, but let's see. Okay, I think I'll just have to get the debugger now because that is getting strange. All right, let's put a debug point here. Okay, so we get into manage transaction. All right, let's step over this for now. So now we have so it says that we are connected, but it looks like we're connected, but we're idle. So let's rerun this again to step over. So it take the managed transaction from us here. And then for some reason it jumped up back up. Okay. All right. Um, I'm sure we're doing something weird with the connection, right? Because there's no way in hell um, that this is the normal behavior. Okay, so let's just look into their example code, right? They have a context, so create context in the background, that's fine. The driver and error, you created the driver, and then you handled the error, and defer handle close, which is context and the driver. Okay, so that's at the end, really. And here session, new session, and handle close. So here execute write, context, session, and this. So insert the person, and then you can run a bunch of inside the transactions. So in this case, this is the total transaction timeout. Let's go into the session configs. These are all the fields. Yeah, nothing particularly useful for us here. So let me take this off screen for a second. Let me try something here, because I am having a weird suspicion that it could be something as silly as this. And if it is, then I'm telling you, I'll be pissed. Okay, and now let's run it. Okay, that's not it. That's good. At least kind of like clarified that it is not what I expected to be. I was wondering that if the authentication isn't actually going through as we would like it to, right? So yeah. All right, now what? Now we still need to figure out why are we timing out here. So yeah, no, let's go the debug route again. This is not okay. Debug. All right, so we're inside here. We're gonna step into all the functions. Okay, so now we stepped into that. Now it went back to execute right. Cast generic session execute right. Now the transaction adapter. Okay. See, it already went into retry mode. Okay. All right. Um so why does it go into straight failure mode? 1 second, guys. Okay, so this is fine. Okay. I'm just looking into the debug mode right now, trying to see if there's anything that I need to like pay attention to. So I had my debugger. I was trying to make sure that like it is going through parsing properly and everything. And looks like it was, but my only problem is why it is so it goes into the session and then runs the function, then goes back to the session here. And that's a bit confusing to me, right? So if I go here, to the test again, I can run in debug mode. So we stop right there. If I click step into, we're only allowed transaction to run, so I'm not really sure how can we force it to like get out of here. Because even if I do this, that wouldn't help. If that doesn't go through, guys, we'll end it here. I'll have a look and I'll come back with a solution for you. Because I'll have to like look into it a bit more because I'm honestly not really sure just yet. Alright. Alright guys, that would be all for today. And I'll look into this and come back with a video solution. And we'll take it from there. I guess the whole purpose of this series is like that we learn things in like real life, not just like in the perfect world. And this is something that we might as well run into, and we need to figure out how to debug it. And if I figure it out, I'll find out a solution and make sure to kind of walk you through what I did to discover it. So until next time, and hope to see you soon.